relative to kind of the cantilever, and it's going to cause a very slight resonance shift. So the resonance, given that added mass, is going to shift slightly to the left. And so if you set your blue bar slightly to the left, then it will land on the resonant peak once that shift occurs. And again, this will be in that instructional video. So once we've set it slightly to the left of our peak, we can now go ahead and start paying attention to our Z_ample. This is a live readout of our amplitude of vibration. So you'll see that right now it's 0.449. This value should be between 0.8 and 1.0. This is where we found the best resolution as well as the best ease of use. In order to adjust that, we'll use this amplitude VPP slider. So if I go ahead and click right here and use the scroll wheel, we'll see that as I increase this value, our Z_ample is increasing. And so, like I said before, we just want it to be between 0.8 and 1.0. So in this case, I'll set it to about 0.9. So once we have that set, we can go ahead and go back to our test probe alignment. And for this, you'll click that. This window will pop up. Just go ahead and click test alignment. And this will show you as the Z piezo extends, because obviously the Z piezo is mounted above the cantilever. If there's any kind of odd expansion where it's at a slight diagonal, or if the cantilever is not perfectly kind of within that slot, then it can cause kind of variances. So you can imagine if the cantilever is kind of like this, and then it's getting pushed down, then that's just going to amplify the effect. So what you want to pay attention to is this actual signal variation. This should never be above 15. If it is, you have to go back a couple of steps. You'll have to remove the cantilever, or you'll have to remove the probe holder. My first recommendation would be kind of loosening that clip, just tapping on the back of the cantilever a couple times, tightening it again, and putting it back in, seeing if it was just kind of out of its spot just a little bit. The AFM will still run with it above 15%, however it does have an added risk of potentially breaking in the process. So that's why my recommendation is, if it's above 15%, to kind of just go back a couple of steps and make sure that that cantilever is set correctly. In this case, the overall variation is 4.1, which is well within spec.
So when we encounter that problem, can we just directly take the probe and then realign the probe, or do we have to do some manipulations in the software?
So you would not need to do anything in the software. It depends on how close you are. The biggest thing is, once you kind of adjust that probe, you'll want to go back up and make sure that that laser spot is still in that same area, because if the probe shifts slightly, then that laser spot, rather than being right there, might be like right here or right here. So you'll want to go back and make sure that your laser alignment settings are still good, that the laser spot on the cantilever is still good, and then that your resonant frequency still looks good.
That's easy.
Okay. So now that we're all set with that, I'll show you how to set yourself into phase. I don't know if you'll do a ton of phase measurements with the samples that you want to run, but in case that you do, it can be kind of interesting with cells. You can kind of start to see different aspects of the cells based on what phase is. This is essentially looking at kind of differences in densities, elasticities. The easiest way I always refer to it is if I knock on this and knock on this. So in vibrating mode, you're essentially tapping over the surface, and so those different material properties can be picked up by the cantilever. So that's kind of how you're able to look at different like polymer mixes. If you have like PMMA and polystyrene, one is softer than the other, and so as the cantilever taps over the surface, it's able to look at that and see that. In order to set yourself into phase, first you'll need to go through the entire process that we just said before. So setting yourself slightly to the left of this blue graph, setting your Z amplitude, and then what you'll want to do is you'll want to go ahead and make note of where this blue vertical line, your selected bar, intersects with the red line. So you'll see amplitude is blue, phase is red. So if we look, you'll see that we're intersecting at about 96, 97 based on this side. And so ideally what you want is you want to intersect at 90, because that's the turning point of the graph. It's going to be at its steepest, and that's where you're going to get the best overall difference in contrast. In order to do that, you'll adjust this phase degree slider. Essentially what this does is it moves the entire phase graph back and forth to change where you're intersecting. So for example, right now I'm at about like 95. So if I go ahead and put in 10, what you should notice is it's about a 1-to-1 translation. So now I'm intersecting at about like 105, 106 or so. So increasing it will shift it to the left. Decreasing the value will shift it to the right. So in this case, if I set this to like 85, might not be enough. We'll see. Actually, I don't think it's enough. Yeah, it's not. So we set it to like 1.6. So basically you'll kind of just have to toy around with this, and as you use it and set it up, you'll get kind of a better idea of how the translations work. See, so now we're at about 105. So let's just do 1.75.